Hello everyone, hope you're doing and welcome back to my channel. Today we're at day 28 of the January daily LeetCode challenge and we again have a very good question in front of us. This I will say is somewhat on the easier side. If you are no very good in terms of the basics of graph traversal, I mean just traversal, okay? I'm not saying like in-depth algorithms. I just meant the traversal. If you're like sure what how to traverse a graph, how to do the BFS, how to do the DFS, if you're even good in that, you will be able to solve this question with ease, okay? With very much ease, okay? So this is I will say slightly on the easier side, so please do give it a try. Even if you are someone who has just begun, I will say please give it a try. At least if you have at least understood what is the BFS and what is the DFS, you can pause the video right here and start trying. Okay. Yeah. Now coming to the question, it's going to be easy question. And if you see the constraints, like before showing, see, just know that in the grid, in the input you are given a grid. Grid means a two-dimensional matrix. Okay, it's an integer matrix. And let's see the constraint first, and then you will get to know why I'm saying it's an easy question. See the constraints here. Okay, let me zoom in. If you see the constraints, you will be very clear why it's easy question. See, the its at max is going to be M10 cross 10 grid. That is at max it is going to have 100 elements. Okay, which is very much minimal. Okay, it's very much minimal. So that's why I'm saying it's going to be a very easy question. And even if you see the each grid, that is each value in the grid is up to 0 to 10. Okay, which is again very small value. Okay, so you don't have to worry much like how overflow will happen in the data type or not. All those things you don't have to worry if you're coding in C++ and Java. Okay, that is something that I want to tell you. And now coming to this question, just see it. 2658 maximum number of fish in a grid. Okay, so what we are given, we just know that we are given a grid basically means a two-dimensional matrix and all the values are going to be integers. Okay, now you are given a zero indexed 2D matrix grid of size m cross n. Okay, just know that it's not a square matrix. Okay, m cross n means both the dimensions can be different. Okay, as simple as that. Where r comma c represents a land cell. Okay, if grid of r c equal to 0, that is if you get a value, if you go to a cell whose value is 0, you have to assume that it is going to be a land cell. Okay, it is going to be a land cell. Okay, as simple as that, right? Then if there is any other value, okay, which is a non-zero value, you can say that any non-zero value which mean that it is a water cell. Okay, just remember the values in that are always positive. Okay, it is going to be 0 or above 0. Okay, there will not be a case where negative value is present. Okay, so there are two things here. If the value is 0, that means it is going to be a land cell. If there is a non-zero value, it means it is having water. Okay, now if Fisher can start at any water cell R comma C, remember they're meaning any water cell. Normally, what happens in graph algorithms in LeetCode especially, they will be giving that we should start at 0 comma 0 and end at m comma n. Okay, something like that. But here it is slightly different. They are saying you can start at any water cell. Okay, they are just saying you can start at any water cell and do the following operations any number of times. Okay, these are the operations. See here, catch all the fish at the current cell. Okay, or move to any adjacent water cell. Okay, there are only two things that you can do. If fisher can start at any water cell, okay, and do the following operations, either it can catch all the what fishes there, or it can move to adjacent water cell. Remember, it can move only to adjacent water cell. Okay, idea here is the fisher cannot go to a land cell. Okay, if it is starting, first of all it has to start in a water cell only, otherwise it cannot start. And if it is in a water cell, it can only go to the adjacent water cell, it cannot go to the land cell. Okay, that is, these are the constraints. Return the maximum number of fish the fisher can catch if he chooses his starting cell optimally, or 0 if no water cell exists. Okay, as simple as that. An adjacent cell of, they are just telling you the definition of adjacent cell. Adjacent cell basically means it is going to be vertically and horizontal adjacent. Okay, they are not telling you about the diagonal adjacent, okay, case here. Okay, it just means vertically and horizontal adjacent. That is, if you're in a cell, okay, then the above cell, the below cell, the left cell and the right cell. Okay, only these are the ones which you can think of traveling if and if that cell is a water cell. Okay, otherwise you cannot travel. Okay, so there are two things here: either each cell is a land or each cell is a water. Okay, as simple as that. In the water cell there will be certain number of fish. Okay, as simple as that. So either you can start at that cell and catch all the fish, or yeah, after catching the fish you can move to the adjacent water cell. Okay, adjacent water cell. But now the question here is where you have to start. If you see the diagram here, see this case. In this case, if you see the water part, okay, here if you see 4 comma 1 is the water part, 4 and 1 1, 2 and 1 is the water part, here 3 and 4 is the water part, 3 and 2 is the water part. Okay, these numbers basically means how many fish are there. So here 4 plus 1 fish are there, here 2 plus 1 fish are there, here 3 plus 4 fish are there, and here 3 plus 2 fish are there. Now the idea here is, if you start, let us say, in 4 comma 1, this part if you try, okay, you will be able to catch 4 plus 1 fishes. Okay, but after that you are stuck because you are surrounded by land cells. For that reason you cannot escape out of that. Okay, so at max you can catch only 5 fish cells if you are starting in this 1 comma 0. Okay, as simple as that. Similarly, either that you can do, or what you can do is you can try with 0 comma 1. Okay, if you try with 0 comma 1 as your starting point, you can catch 2 plus 1 fishes. Okay, similarly you can there is other opportunity that if you start at this particular set, you can catch 3 plus 4 fishes. Okay, and similarly, say it all depends on where you are starting, because see, in this case the water cells are not connected with each other. Okay, if the water cells are connected with each other, it doesn't make a difference where you start, because anyway you will be able to get all the fishes. Okay, in this case, since the water bodies are they are separated, they're isolated, for that reason you will have to optimally start where you are going to start the traversal. Okay, so 3 plus 2. Okay, here in the last one. So if you see, the optimal answer is going to be 3 plus 4, which is 7. So that's why the answer is 7. Okay, as simple as that. So I hope the question is clear to you. The water bodies are isolated. Once you attend a water body, you cannot go to the adjacent cell, the adjacent land cell. Okay, you should only be traveling to the water cells around it. Okay, as simple as that. And because of that reason, you will have to very optimally choose your starting point, because if you start with the see, if you don't choose your point optimally, you will end up getting less number of fishes. Okay, as simple as that. So if you see the example number 2, in this case, if you see, here one is there, here one is there. Okay, rest are lens cells. So obviously we have to either start here, or we have to either start here. Okay, that is 0 comma 0 or n minus 1 comma m minus 1. Okay, in either case you are only going to get one fish, so the answer is going to be 1. Okay, and yep, that is all. And I have already told you about these constraints, right? Now, how to solve this question? As I mentioned, if you know simple BFS or your DCS, you will be able to solve this question. How to do that? See, things are going to be very simple. The approach here should be, see, first of all, as I mentioned, you can start from anywhere. Okay, as simple as that. So what you have to do, use two for loops to go to each of the cells in this array. Okay, that is the first thing. Next, whenever you see a cell which is a non-water, that is non-land. Okay, that is the value is greater than 0. Whenever you see a water cell, you will have to start a BFS. Okay, why a BFS? See is this. Either you can do a BFS, or you can try for a DFS also. But I am going to show you BFS. Okay, what is that? Now see, once, what is BFS means, see, the idea here is, if two water cells are connected, you are going to collect fishes on both of them. Okay, for that reason you will have to do BFS. Okay, and when the BFS will end, the BFS will end either when all the cells are completed, all the cells that are are connected are completed, or you are no, there is no option left for you, but you are trying to enter a land cell. Okay, and there is no other option left. Okay, in that case you will have to enter. Okay, these are the only things. So the idea is, whenever you see a cell whose value is greater than 0, enter it, collect the fishes there, and then mark this value to 0. Okay, these are the things that you are going to do. Now let me show my solution quickly. So see here, I am first of all capturing. Okay, let me zoom in further. See, I am first of all capturing the length. Okay, this is basically going to tell me how many rows are going to be there. Okay, this will tell me how many rows are going to be there. This will tell me how many columns are going to be there. Right now, this is my final answer. And these are the directions. They have also given the directions. You can go through them also, but these are ultimately the ones. Okay, if you see here, they have also mentioned the same. But here I'm using it like this, because remember, if you see any good optimal solution in any contest, they will be traversing it like this. Okay, instead of hard coding it directly in the, like in the loops, they, instead of doing if condition and all, they would have directly coded like this. Okay, this will be the easier way to do it. Next, we are going to define a DFS function. Okay, before the DFS function, I will just show you how this is being called. Okay, so this is what I will show you. See, I'm using two for loops. Okay, I'm going through every cell basically. Okay, if I'm just checking if the grade of I comma j equal to 0, then there is no meaning in continuing that. Okay, that is, there is no meaning in starting a BFS there. Simply continue. Okay, because obviously it's a land cell, I cannot start the traversal there. Otherwise, if it is a non-land cell, that is, if it is a water cell, what I have to do, I have to start a BFS there. Okay, this BFS function will collect some of the fishes for all the water cells which are adjacent to a current cell, and then we will try to capture them. Okay, we will try to consider that as the answer. Okay, now let's see how it's being done. So here the coordinates are being passed. Okay, now what I have to do, first of all, I'm declaring non-local direction answer. Why I'm doing that? See, answer is declared here, direction declared here. So whenever you're referring to something which is being declared outside the function, you'll have to mark it as a non-local one. Okay, so in lead, especially in lead code, you should be doing this. If you're not doing this, sometimes the answer will not be coming correct. Okay, obviously it depends on the compiler, the version of Python they're using, and all that. But remember, make it as a habit to declare non-local stuff if you're referring to something which is being declared outside. Okay, as simple as that. Now, as I mentioned, it's a BFS, so obviously BFS means there has to be queue. Okay, and what is the first node in the queue? The first node is going to be this a comma b. Okay, because that is the coordinate that we are passed. Okay, since the result of this BFS will tell me how many fishes I have collected for all the connected nodes, all the connected water nodes from the current cell. For that reason, I have to initialize the parameter for fishes. This will tell me how many fishes I can collect if I start the BFS at the current cell. Okay, so initially, whatever fish are present in the current cell, that itself is going to be the initial count of this. Okay, now since I have collected the fishes in this particular cell, what I have to do, I have to mark the number of fishes in this as equal to 0. Okay, you can like think of it as a land cell now, but I'm not saying land cell, but you can think like it's a water cell. Still, the fishes here now is made to 0 because I've collected those fishes. Okay, this is being done here so that I do not enter the cell again. Okay, This is kind of acting as stopping condition, as you will see now. Okay, now as you know about BFS, till the queue is not empty, this particular loop will continue. What we are doing here, first of all, we are doing a pop. Remember in the last session what I showed you in yesterday's solution, what I'm doing is, see, append will happen. So append will actually put a value towards the right, okay, and pop will also pop from the right. So what you can do is, if you use a DQ, what is a DQ? DQ means a double-sided queue. You can even pop from the left, okay, if you don't want that. But currently I've not done that, okay. I'm simply using a queue. Both append and pop will happen from the right side, okay. If you want a pop from happen on the left side, what you have to do, you have to use a DQ, and then you have to use pop left function, okay. That will ensure that the even the pop left is having in off one time. Otherwise, if you try to simulate the same thing with the simple list, it will take off one time to pop from the left, okay. As simple as that. Always pop from right and up and from right happens in off one time. If you try to simulate it from the left hand, you will have to spend off one time, okay. If you don't want to do that, you have to use double-sided queue, okay. This is just extra information. We are not going to use it here, okay. Just extra information, because for people who are following my code from a long time, they should be knowing these things, because I'm just telling you when and where I'm using what. In this case, I have not used it because if you see, the constraints here are very minimal, okay. It's a 10 cross 10 matrix. I don't have to think about much here, okay. As simple as that. Now, yep, I'm doing a pop. These are the x and y coordinates of the node which is being popped. Then I'm going to all the x and nodes of the current node. Okay, how to do that? See, I will go from I comma j in direction. That is, I am going to see, this is going to be my I, this is going to be my j, and similarly for all these cases also. Okay, for all these cases, what I'm going to do? See, for I comma j in direction, add I to x, add j to y. Okay, I will get my double x and double y. So this double x and double y is going to be actually a adjacent cell for my current cell. Okay, now this double x double y can be outside the grid also. For that reason, I have to check that if double x not in range n and or double y not in range m. Okay, remember this is our condition. Even if one of the coordinates are outside the grid, still the whole cell will be outside the grid. Okay, if that is the case, simply continue. That is, go to the next iteration. Okay, this current adjacent cell is not in the grid, right? If that's not the case, that means if the cell is in the grid, then what you have to do? We have to check if the value is equal to 0. Okay, as I mentioned, this will now act as a deterrent condition for it. Okay, so if the grid has already been made 0, or by default itself it was having 0 value, or we have already corrected the fishes there, it has been made 0. In either of the cases, we will continue further. Okay, we will not go to this cell anymore, because this cell either we have already visited and explored, or this is already a default cell, already by default a land cell. Okay, in either cases we will not go to that cell again. Okay, as simple as that, in both ways. So what I'm doing is, in the graph, in the given input itself, I am doing the changes. Okay, this sometimes is not advisable, because some okay, in a face-to-face interview, maybe you can basically ask this to the interviewer, whether you want me to like change in the given input itself, or you want me to like maintain a separate a cache or a DP function, hold to DRA, and do the maintain the records there. What you want. If they're okay with you in making the changes in the given input itself, you can do that. I have done that here. Okay, as simple as that. Because if I just see with this small optimization, I am able to save O of m into n space complexity. Okay, this is the reason why I'm doing that, right? Next. So yep, we are here. So if this cell is having some fishes, then we will explore it. Okay, otherwise we will not be exploring it. Okay, now if we come to this part, then what you have to do, capture the fishes that are there in this adjacent cell. Okay, and then mark the number of fishes in this equal to 0, and then append this cell in the queue, because we want to explore its adjacent cell now. So, okay, so just remember the approach here. Whenever you are appending something to the queue, okay, you'll have to first collect its wishes, and then you have to mark the value in the grid as 0 for this coordinate. Okay, same thing if you see we have done here. First, I'm adding something in the queue. I have collected the fishes for that coordinate, and I've already made the coordinate as 0 for that. Okay, I made the value for as 0 for that coordinate. Okay, the same thing I have to do. There are three steps here. Okay, adding it into the queue, collecting the fishes, and making the fishes as 0, marking the fishes as 0. Same thing we have done here, collecting the fishes, marking the number of fishes equal to 0, and then appending it to the queue. Okay, as simple as that, right? Once I have done that, this loop will keep continuing till the queue is not empty. That is, at least if a node is there which is still unexplored, then we will be continuing this BFS function. Okay, this value will be continuing. After we come out of this value, what will happen? The number of fishes that we have collected because of this BFS will be showed here. Okay, so at last we'll just check whether the correct answer that we have collected is more, or the previous answer that we might have had collected, that is more. Okay, so I'm just doing answer is equal to max of the previous answer comma the fishes. Okay, in either case, whichever is the maximum value, that will be updated in the answer now. Okay, so at last if we see, we are getting the answer. Now let us say I just print this grid at here at this stage. Can you quickly tell me what will the output? The output will be all zeros, because in every cell now we would have wasted, and we would have only corrected the fishes, and we would have made the value in the cell equal to 0. For that reason, if you print this statement here, what we will get is all that is a grid matrix with the same n corresponding dimension. All the values will be 0. Okay, that is something that I just want to show you. Okay, as simple as that. So often that was all the solution. So as because see, one more thing here, don't think like for every okay every value this okay for every water cell this will be called. Okay, it's not the case. As I mentioned, since I am making the value is equal to 0, so what will happen is, let us say I've already visited the cell, I have made the value 0. So when I am here, okay, then this condition will become true for that. Okay, let us say this I comma j was a water cell, but since we have done a BFS for some other coordinate and we have come to this also because it was connected to the previous coordinate, so now this value will also be becoming 0 and we will not continue with this again. That is, we will not, okay, explore this again because we already done that. Okay, so this is going to be most optimal solution because here we are not doing anything, we are not doing we are not redoing any calculation. Okay, everything is done only once and in a most optimal way. Okay, if you talk about the space complexity, see here there is a trick. Okay, it's I will say it's slightly tricky one. See, if you see overall, this is the only thing that I'm using. Okay, and it's obviously constant length. Other than that, we are not using anything. So ideally, it should be O of one space complexity. Okay, but there is a catch here. See, here we're using a queue. Okay, this queue will be storing the elements. Okay, at a time it can, like in each iteration, basically it will be, see, in each iteration what is happening, I'm going to all the four essentials, and in the worst case I'll be all four of them in the queue. Okay, so see, this queue is the only thing that is going to consume some space now, which is going to be variable. Okay, rest all things are going to be constant. So if you assume, like, see, in the worst case what can happen, see what, in a single iteration what is happening, you are popping note out and at max you are pushing four nodes in. Okay, so there is no way to directly assume like how to see the space constants for this. But if you are trying to consider, in the worst case it will be, on the upper limit be having O of m into n cells. Okay, for that reason I mark the space complexity as O of m into n, and obviously the time complexity, if you see you're using two for loops, so obviously the time complexity will be O of m into n. Okay, but this space complexity, some people may argue that it's O of one space complexity, but I have, submitted this solution in multiple compilers, and in some of them I'm getting O of m into n complexity. For that reason I'm writing it here as O of m into n space complexity. Even in the lead code there is a, option to check how it will show you the basic space complexity of a solution. You can try that. I got m into n there, that's why I'm writing here m into n, but my like gut feeling is that it should be O of one. But still, because this thing is not very, like, it's not very simple to, predict how many values will be there in this queue at a time. But as I mentioned, in a single iteration, at max four values will be inserted in the queue and one value will be popped out. Okay, so net three will be inserted in the worst case. So again, with that we cannot predict how much space complexity it is going to take, but that's the reason why I'm, showing you O of m into n. Okay, because remember, it's a higher limit. Okay, this is always the higher limit. So in the higher limit we'll be having almost all the values here. Okay, as simple as that. So I think that was all for this question. What we did here, we learned BFS. We are, first of all, see this optimization, this is something very important because you'll have to think of a condition here which will help you to see. Normally what we'll do is, in a BFS we will also be maintaining a visited set. Okay, if you see, have seen my previous solution, if you have seen any BFS solution, for that reason there will be visited set. Okay, that will be maintaining in which cells you have already visited. But in this case that is not needed because we are marking those cells as 0 and we are using this as a condition to decide whether we should explore a cell or not. Okay, for that reason in this case we are not using any visited set, and for that reason I'm claiming it's going to O of one space complexity. Okay, but yep, there are other cases also. It's not very clear, like whether this, like how much space complexity this particular part is contributing, that is not very clear. Okay, for that reason I am not claiming it to be of one solution. That's why in the worst case it should be of m into n, and I've written that here. Okay, yeah, and that was all for this video. I have not given a Java solution for that because I felt this was slightly easier side. I want you to try the Java solution, though I was like working on getting the Java solution, but still it's a easier side. Like there's nothing much happening here. Okay, so see, these things you can easily do in Java. That's why I'm not doing that here. Okay, there's no hash rate involved, and nothing's involved. Just a queue is being involved. You can use array list for that reason. You can use this as an array list. You do that and pop the values and get it. So rest of things are very simple here. Okay, for that reason I want you to basically do that and get it. Okay. If you have any doubts, please do raise it in the comment section. I do read every comment here. And if you want the Java solution also, I can provide that. Okay. But I want you to try that first. So as I mentioned, this was slightly on the easier side. Previous days questions were really good ones. I'm definitely expecting you to go and try that out. Okay. Especially previously, like 1 or 2 days back, we had hard question. I want you to try that out. It was a really nice question. Okay. The level was really good. So yeah, that was all for this particular video. And yep, see you tomorrow. And if you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. See you tomorrow. Thanks a lot.